Now we're going to look at the examples dealing with the angles of a triangle, whether those are interior angles or exterior angles. In this first one I have 5 different angles that I need to find the measure of. And what I'm going to do is I'm going to find the measure of angle 1 first. Now to help me with that, I'm going to highlight just the triangle that I want to work with, and then I'm noticing that angle 1 can be an exterior angle of that triangle. And what I just learned about an exterior angle and its remote interior angles is that if I add the measures of the remote interior angles together, I will find the measure of that exterior angle. Therefore, I'm going to take the 32-degree angle and the 38-degree angle, add them together, I'm going to end up with 70 degrees for the measure of angle 1. Already calculated one of those angle measures. That one's done. Now I'm going to get rid of this so it doesn't confuse me later. I don't need those anymore either. Now I'm going to look at this and I'm going to go, well, now that I know the measure of angle 1, the measure of angle 2 should be pretty fast because I know these two angles together is going to equal 180 degrees. Therefore, to find the measure of angle 2, I need to take 180 degrees and subtract out the 70 degrees from the measure of angle 1. I know the measure of angle 2 is going to equal 110 degrees. I'm going to put that in there so I don't forget that. I'm going to eliminate that so it doesn't confuse me. 2 of the angles done. I'm going to move on to angle 3. Now in angle 3, we have multiple ways to figure this one out. What I would look at first is finding the measure of this angle. Now I know that we don't need it for the problem, but it will help us find the measure of angle 3. And what I look at is the measure of angle 1 and the measure of the angle that I have starred. Those are vertical angles, therefore they have to be congruent, and this one's going to be a 70-degree angle. Let me get rid of this now. I can leave the congruent mark. Now I can look at my triangle right here, and I know the 3 angles in a triangle have to add up to 180 degrees. I know 2 of them, I should be able to find the 3rd. What I can do then to find the measure of angle 3 is I can subtract those other 2 angles. I'm going to take the 64 and the 70, I'm going to add that together and then subtract it from 180 degrees. Now I'm going to end up with 180 minus the 134 degrees, give me a grand total of 46 degrees for the measure of angle 3. I'm going to go back to my picture. I'm going to put that 46-degree angle right by the measure, or right by angle 3. Therefore, I won't forget it. Let's get rid of that so it doesn't confuse me later. Now I have the measure of, I'm going to go to the measure of angle 4. And I have a couple different ways to do this. I'm going to take and use the exterior angle theorem again, because I'm going to look at angle 4 as being an exterior angle of this triangle. And the reason I did that is because now I can look at the 2 remote interior angles of angle 4, those 2. And what I can do is I just need to add them together, because the exterior angle theorem said if I add the 2 remote interior angles together, it's going to equal the measure of the exterior angle. 64 plus 38 puts me at 106 degrees. Oh no, sorry. My addition is off there. Let's try that again. Let's try 102 degrees for the measure of angle 4. I'm going to put that in here. 102 degrees. And all I have left now is the measure of angle 5. Let me get rid of these 2 because I don't need those anymore. And now I'm going to go back and look at one triangle. This triangle right here. And I know those 3 angle measures have to add up to 180 degrees. Therefore, I can find the measure of this one in a similar fashion to the way I found the measure of angle 3. I'm going to come down here for the measure of angle 5. I'm going to say, well, if I take the grand total and I subtract out the 2 angle measures that are in the triangle, the 102 degrees and the 41 degrees, I will end up with 143 degrees here. Subtract that from 180, and I'm going to end up with 37 degrees for the measure of angle 5. And I have just calculated all 3 angles, or all 5 angles in this picture created by a bunch of triangles. Let's go on to my next one. Here again, I want to find the measure of all 3 angles in the triangle. Notice it gives me the measure of all 3 angles in the triangle in terms of x. Well, now you got to think back to your triangle angle sum theorem, which says if you add the 3 angle measures together, it's going to equal 180 degrees, and that's what I'm going to do. I'm going to take all 3 of those angles. I started with angle C for whatever reason. Here's angle A, and here's angle B. There's the measure of those 3 angles. The triangle angle sum theorem tells me that when I add those together, it's going to equal 180 degrees. Now I have an equation that I can solve, figure out what x is, and then in the end, plug it all back in. I'm going to start this off, and I'm going to subtract 5 from both sides of the equation. Now the reason I'm doing that is because if you look at the negative 12 plus 8 plus 9, that's going to equal a positive 5. So I'm going to subtract that out, and now all I have to worry about would be the x's. So I have 8x plus 3x, which is 11x, plus 4x is 15x. I have 15x, oopsie, put that on the wrong line, I'm sorry. Let me fix that. So I subtracted 5 from both sides, which gives me 15x equal to 175. Divide both sides of my equation by 15. Find out that x comes out to be 35 thirds if you simplify that fraction. Both of those are divisible by 5, and that's what we end up with. Now, I ultimately wanted to find the measure of angle A, the measure of angle B, and the measure of angle C. So I'm going to come down here, I'm going to start with the measure of angle A. Let's go with this. So the measure of angle A, according to my problem, says it's 3x plus 8. So I'm going to take 3, well, times my x, that was 35 thirds, and then I have to add on 8. Well, this one works out nice. The 3's divide out, and we have 35 plus 8, so 43 degrees is the measure of angle A. If I move on now, go to the measure of angle B. That one's 4x plus 9. The measure of angle B equals 4. I have my x, which is 35 thirds again. Funny looking 3. And then plus the 9. Now on this one, the fractions don't work out as well, but if you were to punch that under your calculator or work it out long way, it comes out to be 55 2/3 degrees. Yes, things can come out, or angles can come out to be fractional measures, the degrees. And then last but not least, we have the measure of angle C, which is 8x minus 12. So the measure of angle C equals 8. We already know what x is. And then subtract the 12. And this one, again, fractions don't work out as nice as they did in angle A, but if you were to calculate it by hand or punch it on your calculator, figure out this one comes out to be 81 1/3 degrees. Now again, we didn't have to find the measure of angle C this way. We could have added these 2 angle measurements together and then subtracted from 180 degrees, but we still would have ended up with 81 1/3 degrees. So there's another example on how we can use the triangle angle sum theorem to calculate the measure of 3 angles when they're given to us in terms of x. That's going to conclude the example portion of the angles of a triangle.